Find the derivative of f of t equals 1 minus 2t quantity raised to the 3 power, a, by using the chain rule, b, by expanding the expression and differentiating the result. For part A, f of t is made up of an entire expression, 1 minus 2t, all raised to the 3 power. The derivative will therefore require the chain rule, since we have an entire expression inside of another function, the 3 power. The outermost function is the 3 power, so the derivative, f prime of t, will make use of the power rule. We'll bring the power down, 3, leave the inside alone exactly as we see it, and then subtract 1 from the power. That'll give us a 2. But since the inside of the power is not just a t, but rather an entire expression, that is where the chain rule is needed, and we have to multiply by the derivative of the inside of the 3 power, or the expression that's in there. The derivative of 1 is 0, the derivative of negative 2t is negative 2. That completes the chain rule. Since everything is multiplied here, the 3 and the negative 2 can be put together, multiplied to negative 6, and we have negative 6 times 1 minus 2t quantity squared for our derivative. For part B, we're going to first expand f of t. F of t is 1 minus 2t cubed. That means it's 1 minus 2t multiplying itself 3 times. Now we can pair off the second and third and FOIL that out. We'll leave the first alone for now. FOILing out the second and third, first 1 times 1 is 1. Outside, 1 times negative 2, t is negative 2t. Inside, negative 2t times a 1 is negative 2t. Combine those, that'll be negative 4t. And then last, negative 2t times a negative 2t is a positive 4t squared. And now we can FOIL out this, which is 2 terms, 1 minus 2t, multiplying 3 terms, 1 minus 4t plus 4t squared. It's going to give us a total of 6 terms. We're going to start with the 1 FOILing into each of those 3. So f of t will be 1 times 1, which is 1, 1 times negative 4t, which is negative 4t, and 1 times 4t squared, which is 4t squared. Now we're going to FOIL the negative 2t into each of those. Negative 2t times 1 is negative 2t. Negative 2t times a negative 4t is a positive 8t squared. And negative 2t times a 4t squared is a negative 8t cubed. Let's combine together like terms. There's only one constant, 1. There's a negative 4t and a negative 2t. Combine those two. Negative 4 minus 2 is negative 6t. There's 2t squared terms. There's a 4t squared and an 8t squared. 4 plus 8 is 12 t squared. There's only one t cubed term, negative 8t cubed. At this point, f of t is made up of terms that are added or subtracted together, so we can take the derivative of each of those separately and add or subtract the results accordingly. So let's find the derivative f prime of t. The first term, a constant, will be a derivative of 0. The second term, a constant times t, will be a constant, negative 6. The third term will follow the power rule, bring down the 2, multiply it with the 12. 2 times 12 is 24. T raised to the subtract 1 from the power, and that'll give us a power of 1. And then the last term will be a power rule. We will bring down the 3, multiply with the negative 8, negative 24, and then t raised to the subtract 1 from the power, and it'll be t squared. This expression is factorable. First of all, we have a common factor of a negative 6. Let's factor that out. So we have negative 6 times a positive 1 minus 4t and plus 4t squared. This expression is trinomial factorable. It factors into a 1 and a 1 because of the 1. We have a positive 4t squared and a negative 4t, and that means it'll be a negative 2t and a negative 2t. Since those are the same, we can write that as quantity squared, and you see that matches exactly the derivative that we had resulted in part A. F prime of t is negative 6, 1 minus 2t quantity squared.